Bo Lotto is a neuroscientist based at University College London. He specialises in human perception, especially how we perceive colours. Could you start off by telling us a little bit about yourself and what got you interested in colour and perception of colour?
So a bit about myself. So I'm a neuroscientist at University College London, and I study perception, and in particular perception of color. And so it's, why would anyone want to study color? And the answer really is that color is the simplest thing that your brain does. And as I often say, even jellyfish see lightness and then they even have a brain. And why is that important? The reason is, if we could understand how we see color, and if we could pull out the principles of that, then what's true there has to be true everywhere else. Has to be true all the way up in everything else that we do. So studying color is about really trying to study the essence of what it is to be human.
How do we see, and how does past experience help us to make sense of what we are seeing?
Okay, so how do we see? We don't know. We don't have a clue how we see, right? Basically, we don't really know how the brain works, how the brain takes sensory stimuli and turns it into this conscious perceptions that we experience. We don't know how that works, right? But we're starting to get some clues. But one of the reasons why we don't know how that works very well is because we've been approaching the problem with the wrong assumptions, okay? Your assumptions define the kinds of questions you ask, and therefore the kinds of answers you look for. And you can never ask a question without an assumption. And the significance of the assumption when it comes to neuroscience is we've assumed that the brain evolved to see the world as it really is. And if you think that we're literally seeing the world as it is, and that's the task of perception, then you're going to do experiments, you're going to explore the brain with that framework. But what if your brain didn't evolve to see the world as it really is? If that's true, then we're asking completely the wrong questions. And that's one of the reasons why we know very little.
From your point of view, what is colour for?
Simply put, color enables us to distinguish between surfaces that we wouldn't normally be able to distinguish between. So if two surfaces reflect the same amount of light to your eye, then if we didn't see in color, they would look exactly the same lightness. But if one reflects more short wavelengths than the other, then while they might appear the same lightness, they now appear different colors. And that's what color is for. It better enables us to distinguish surfaces that reflect the same amount of light, but different qualities of light.
Is it then true that we see in only 4 colours?
Yes. So this idea that we see in 4 colors is potentially quite confusing for people because they think that, well, I literally see millions of colors. And in fact, that's true. I can make subtle distinctions between different shades, millions of different shades, we can see on our computer monitor. And the ability to see the distinction between one spectral distribution, one wavelength, and another is called a just noticeable difference. How much do I have to change this before I notice a difference? And when I do that, again, I can see millions of changes. And yet, all those changes, all those colors get categorized in 4 different ways. Right? And there are only 4 categories of color, which is red, green, blue, and yellow. Everything is a combination of those colors. So orange is the combination of red and yellow. Purple is a combination of red and blue. And so basically we have 4 categories of color. So why do we see 4? Again, no one really knows.
Can you tell us something that you're working on at the Lotto Lab at UCL at the moment?
What we're discovering is that through color, context is everything. Your brain did not evolve to see absolutes. So first of all, color doesn't exist in the world, right? There is physically no color out there. You close your eyes, color disappears, right? Light is not colored. Color is literally a physical manifestation of your brain. That's where color lives. In fact, everything that you see exists in your head, which is an amazing paradox, because what we see seems to be out in the world in front of us, but we're projecting that literally in front of us. So what color demonstrates, and we're learning, is that your brain didn't evolve to see absolutes, it evolved to see relationships. And more significantly, it evolved to see what those relationships meant for your behavior in the past. And what we're learning is that color, like everything else, is seeing a meaning. It's not a cognitive meaning, but it's still a behavioral meaning. And with that type of framework, we're better able to understand the mechanisms then about how your brain sees.
Could you take us through one area where there's been a practical use of what you've researched?
Yeah, so what's practical about what we do? I mean, put it another way, who cares? I suppose is another way of phrasing the question. And I've approached that in a number of ways. One of the ways the practical outcome is this conversation is one example. It's ultimately trying to get people to see things differently. And if you can give them the principles by which your brain sees differently at the level of color, then maybe they can apply those principles to other things that they do in their life. So the way they make decisions, to get people to enable people to consider the possibility of being more creative, more compassionate, more courageous. So to me, I see that as a potential direct outcome of thinking about how your brain deals with color vision. It's about applying the principles. It's about applying a framework, which is fundamental education as well.